Okay, foundations and pre-cal 10. Let's get after it. We are going to look at what people despise because it makes them uncomfortable. Word problems. Because setting up a word problem with one variable is hard enough, but here we're going to set up a word problem with multiple situations. Now, this is that real life stuff. And yeah, is this a real life scenario? Yeah, to an extent, it most definitely is. So how do we do this? Well, the notes provide some pretty detailed examples on my website, but let's do a few of these together and see if we can make things a little more clear. So here's a word problem. So adult tickets for a school play are $12 and children's tickets are $8. So you can see um, we kind of have a setup on the table below I'll talk about in a second. Now, if the theater holds 300 seats and a sold out performance brings $3,280, how many children and adults can attend the play? So what we have is we have this set up in two different scenarios. The first one is we know that there are 300 seats, which means regardless of the number of adults, and we're called adult tickets X, we call children's tickets Y, okay? If you add those things together, there's 300 seats. And it doesn't matter what they are with respect to X and Y right now, but we know that that is not going to change. If X is 299, there's only one child seat. If X is 50, then there's 250 child seats, right? That's what that statement means. Now, it also tells us that adult tickets are $12, which means that 12 times an adult ticket is worth $12. And that means, if X is 1, it's $12. If X is 2, it's 24, it's 36. So that statement there shows that it's $12 per adult ticket. And then children's tickets are $8. So this statement here shows that it's $8 per child's ticket. And we know that if you sell all 300, you get that much money. So it means 12 times X plus 8 times Y equals 3280. So we've created the systems of equations. Now, looking at this, you could add them together. You can use the addition method, but since X and Y are both given without a coefficient here, I'm going to use substitution. So what I'm going to do is I'm going to subtract X from both sides, and now I have Y equals negative X plus 300. And I'm going to sub that into this equation. So now I have 12X plus 8 times negative X plus 300 equals 3280. Now, we just work that through, water bomb, and you get 12X minus 8X equals 2400, plus 2400 equals 3280. Combine your x's and subtract 2400 from both sides. You get 4x equals 3280 minus 2400, so 880. And then you divide both sides by 4, and you get that x is equal to 220. So what that means is that there were 220 adult tickets sold, and then we can sub that x value into this manipulated equation. Y equals, negative, and then 220 plus 300, because if 220 tickets went to adults, then how many were left over to go to kids? Well, Y equals 80. So what does that give us? That gives us 220 adult tickets and 80 kid tickets. So you've solved a system in that respect. All right, so that is how you tackle a word problem. So let's look at another one. And what I've done is I've given you the tables. The goal here is that you can create these tables yourself. So a small airplane makes a round trip, or makes a 2,400 kilometers. So you're pulling out important information in 7.5 hours. Okay, now makes the return trip, so same amount of distance, you can see here, right? 2,400 to 2,400 in 6 hours. So there's a differential in speed. So why? The plane travels at a constant speed and the wind blows at a constant rate. So what you've done is we've set this up. We go, okay, well, why don't we let x be the speed of the plane? And then we let y be the speed of the wind. And that's where these statements come up with, okay? If you are traveling with the wind, then your speed plus the speed of the wind, right, gives you your total speed, and then your speed minus the speed of the wind gives you your total speed. So you have those two situations there, right? And now for just a second, we need to look at what it means to travel in a vehicle or a plane or a train or whatever. Speed. What is speed? Speed is distance divided by time, kilometers per hour, right? Now we have distance and we have time. We don't have speed, but we have speed with respect to some variables. So let's set this up. Multiply speed equals distance times time, and that gives you speed times time equals distance. And we can use that because we know time and then variables for speed. So we have 6 times x plus y is my distance of 2,400 kilometers. And we know that 7.5 times x minus y is equal to 2,400. So we know those two situations. Okay, now before you start multiplying everything by everything, let's see if we can actually divide 2,400 by 6. Because what we do is we'll divide this entire equation by 6, right? Divide by 6, and yeah, that'll cancel. And then 2,400 does in fact divide by 6. You get x plus y equals 400. And then just check, can you divide 2,400 by 7.5 and get a non-decimal answer? And it turns out we can, because then that gives us the statement x minus y equals 320. This just makes things a lot simpler. Now you could have water bombed in, you could have got equal opposite sign variables, canceled them out, so on and so forth, but this just makes life a lot easier. Because now when we add these together, my y's cancel, and I get 2x equals 720, which means x is equal to 360 kilometers per hour. That is my speed of the wind, or sorry, speed of the plane. That'd be really fast wind. Speed of the plane. And now I can just plug that in. So now I have 360 plus y equals 400. Well, you could do that with algebra, or you can just say, well, that's obvious. Y is equal to 40. So you get the speed of the wind is 40 kilometers per hour. Now, I don't have room on the slide. Do your due diligence, check it out, but everything should match up and you get your two solutions. You've solved a system of equations using a word problem. So let's look at one more. This one can be relatively challenging to build the table, so that's why I helped build it for you. So a chemist has two acid solutions. One's a 50% solution and one is an 80% solution. So remember that 50% is equal to 0.50, which is what that is in the table there. And then 80% is equal to 0.80, which is what that is there. So how much of each solution should be mixed together to obtain 100 milliliters of a 68% solution? So that's 68% times 100 milliliters. So that is where that equation comes from. So we get this equation. We get 0.5, I cut the 0 off because it's unnecessary, x plus 0.8 y should be equal to, well, 100 times 0.68 is just 68. So 68. Now, the other equation we get is we have 100 millimeters of solution. So it just means that x plus y should be 100 millimeters. Or sorry, milliliters. Now, what's the best way to approach this? Should we use substitution? Should we use addition? Yeah, you know what? Let's use substitution. I'm going to subtract x from both sides, and that's going to give this equation as y equals negative x plus 100. And I'm going to sub that into my decimal equation. So I now have 0.5x plus 0.8 times negative x plus 100 equals 68. Now, you could use your algebraic tools to get rid of the decimals, but we have calculators. We can use decimals at this point in our math career. So 0.5x, and now I'm going to multiply that into there and into there, and I get minus 0.8x, and then plus 0.8 times 100 is 80, and that equals 68. I'm going to combine my x terms here and subtract 80 from both sides. I get negative 0.3x equals negative 12. And then if you take your calculator and you divide negative 12 by 0.3. Now, negative 0.3, so in this, the negatives are going to cancel, so our answer is going to be positive. So 12 divided by 0.3, and you get the answer x equals 40. So that means we had 40 milliliters of our one solution, our 50% solution, and if our two solutions need to add up to 100, well, yeah, you could solve this in a mathematical equation, or you could just look at 100 minus 40, well, that means y is 60. So you get the two concentrations, or the two amounts of each concentration, 40 milliliters, 60 milliliters. The table is going to be the hardest thing to do, but the most important thing to do. I know I added them here, but that's what you want to get comfortable building. These are challenging, these take time, and they're not always just going to happen. It's not necessarily a one-size-fits-all approach. So like I've said many times, be comfortable being uncomfortable. Try your best, and we can work through these together. Okay, great work.